was really about the Heyfield Community Resource Centre putting the question out there. You know, we're going to do this, we'd like to investigate a microgrid in Heyfield. We'd like you to be part of it or be considered being part of it. And of course, you know, we are part of the community. We do a lot of things in the community, and being part of the microgrid is an obvious place to look at. Ash is a very large user of electricity and the potential to be a very large generator of electricity. So it's important that we consider the Heyfield microgrid in our thinking going forward in the business. To date, we've been involved with understanding what the Heyfield community is doing with the microgrid, and that's on the user side. And on the generator side, we've been doing our own feasibility as to whether we could be a net generator of electricity. The feasibility study we had done by UTS and Federation University is really good because it gave us a table in which you can enter the possibilities to predict what the market might do. We generate 85% of our energy needs now using our sawdust as thermal energy for our kilns, and thermal energy is about 85% of our total energy needs, with electricity and diesel being the other 15%. Ash being such a large user of electricity, it means that we've got to be considered in how we use our electricity and how the microgrid may feed in, or in fact our own electricity generation feed out and into the Heyfield microgrid. It's very important that we are part of that equation, particularly because of our size, our energy needs and our potential to generate large amounts of electricity in times when solar is not operating. The beauty of our project is that our large silos of sawdust are stored energy. They're big batteries, and through solid fuel gas turbines they are immediately dispatchable. So it's a fantastic resource. So the cost side of it, that's not an issue. That we've got the big batteries, we've got the resource, and we could put in the generation capacity. The issue comes back to what does the market look like in the future? What does it look like in the daytime when around about 80% of our operation operates? What does it look like in the night time when about 20% of our operation is operating? Could we buy cheap electricity cheaper in the daytime than what we could generate it ourselves through using our byproduct? Or do we not? Or is that, you know, what does that look like? What does the cost of power at night look like? What would we get for that power if we sold it? What would we have to pay for that power if we had to purchase it? So those issues are, you know, enormous. They're so wide-ranging. It means the risk profile of the project at the moment is large. I think having some transparency about the poles and wires would be really helpful, because we pay very large network charges. About 45% of our electricity costs are actually network charges, not generation costs. So you've got those issues. How, if we generated our own electricity, what does that do to poles and wires? If Heyfield generated its own electricity, because everyone in Heyfield's paying for poles and wires, whether they know it or not. And so what does that do for it? And in a domestic thing, you're paying around about 30% fixed network charges. We're paying about 45% network charges. So it's a big factor in any cost-benefit analysis of whether you do something or not, is understanding what happens to poles and wires. Do you get charged for them because they're there, even though you're not using them? You are using them, but in a microgrid, how does that work? It's a complex situation. What we need is a constant supply of electricity. We can't afford for power to, you know, fluctuate in its supply to us. You've got a lot of big motors running. You've got a lot of PLCs and computer-generated optimisation happening. If you have fluctuations in power, you've got a major issue in operating. So in order to put a solar capacity in to help us with our generation, we also need to put in a large battery store. And at the moment, that doesn't stack up for us. I think it'd be great if Heyfield could achieve self-sufficiency in electricity, provided it stacks up feasibility-wise. The last thing you'd want is everyone to be involved. We put in a lot of money, we get things going, and because of the generation of power elsewhere, it means that either your power in the daytime is too expensive, or your power at the night time is, doesn't work out either. I think the feasibility study has to work so that people in Heyfield, by generating their own electricity, are actually better off.